well, we have our function. We have all the rules, right? We're going to use a graphing calculator to graph each function below. Another thing you're going to, well, it might help. You might want to get 4 colors of colored pencils. If you don't have them in your pencil bag, just come pick 4 colors. It doesn't matter which colors. 4 colors. Sorry.
I'm not doing it.
Again, it really doesn't matter which 4 you use.
Do you have a charger I can use?
There's one back by the pencil sharpener.
May I use the side charger?
Yep. I'm going to be using these colors. It's purple, green, red, and orange. Not even the real ones, though, because I can't find my actual colors. Put them somewhere. Anyway, okay. So the reason we're going to do this is because I want you guys to be able to try to match the colors up with what it's going to look like on the graph when you graph the when you use the graphing calculator. Okay. So I've got my graphing calculator ready to go. And on the paper, it says use it to graph each function. It says to sketch the graph, meaning it's not going to be incredibly accurate. You're just going to do the best you can. No, don't use a pencil sharpener for colored pencils. Just use the little handheld purple one.
It's a pencil.
Okay, well, I couldn't see what he was doing. So it sounded like, hey, I need to sharpen my colored pencil. There's no pen in there. Okay. So we're going to go ahead, and guys, it's really kind of weird how you have to enter this. So if you look at number 1A, you're going to put y equals, that's not the hard part.
Wait, we're on the graphing calculator, right?
Yep. Math tools, graphing. And then I'm going to put the 2, and then I'm going to choose the parentheses. Like as I add things, it's going to graph what it thinks I'm going to have. So do you all see how that's the graph of y equals 2? The red? Obviously that's not where I'm stopping. Then I'm going to put my parentheses, 2, close the parentheses. And then to get an exponent of x, I have to choose a to the second, but then I have to backspace and change that 2 into an x. And now I've got this graph. Yes?
You can also click the B. And then it uses your stick too.
It doesn't put the 2 there?
I mean, yeah, it doesn't. I don't put the 2 there. You can like click whatever you want.
So it shows up blank and then you can put the 2? Fair enough. So for me, this is red, so I'm going to use red on my paper. And I'm just going to sketch what this graph looks like. Obviously, I want the y-intercept to be the right thing. So what is my y-intercept here? 2. So I'm going to plot the 2 on my graph. Right? And then I can see that it goes through like -1, 1. And then it looks like it goes through 2, 8. And that's really all I can see. Unless I zoom out, I can see that maybe it goes through like probably 3, 16. But I can't show that on my graph. So what I have here is, then I'm just going to draw as best I can connecting those points. I'm going to put my arrows because that's what's happening. It's going on and on forever and ever. everybody with me? Okay. So now I'm going to go back to my graphing calculator, and I'm going to click next to 2, and I'm going to make a second graph. I'm going to do B. So this time I have y equals -2 times 2. This time it looks like that. And I would have told you what colors to get to match the graph on the graphing calculator, except I did this 3 times and every time it gave you different colors for the different lines. So if you have blue, awesome. I don't. I'm going to use purple for this next one. So similarly, I'm going to have a y-intercept at -2. Looks like -1, -1. And then I'm guessing 2, 8. Or excuse me, 2, -8. Yep. And so I'm plotting those points. And then I'm going to connect them just like I did.
Oh, whoops, I put that on the same graph.
Oh.
Oh, let's say.
Okay. Well, just like maybe drew like zigzags and then draw this one over here.
I connect my dots.
Okay, perfect. So the next section says without using a calculator, but we're not going to do that. We're going to use a calculator for this next one, right? So we're going to do the exact same thing. And the reason it has these X and Y charts here is because we would choose like -1, 0, 1, and 2. We're just going to ignore that those are there because I was trying to figure out a way to have you do it without a calculator. It's just not worth the hassle. So let's go ahead and do the exact same thing. So I'm going to click on my third space for another graph. And I'm going to do y equals 2 parentheses. And then here, if you just choose 1 divided by 2, it'll give you the fraction. And then you just click on the outside for the parentheses. And then click again on to close the parentheses. And then to the x power. So I'm going to use green for this one since I have a green.
Wait, do you want it all in like one graph?
Nope, we have separate graphs for all of these.
No, I'm saying like so like this.
If you already got rid of the other ones, that's fine, but having them all in the same graph does help to kind of see if they were layered, but that's okay. So it looks like I have another similar. I have 0, 2 is my y-intercept, and then I have 1, 1. Then it looks like I have -2, 8 again. So if we had to list what our ordered pairs were, we could say -2, 8, 0, 2, 1, 1, and just leave it at that. If we were to put in -1, we are going to get a weird, not whole number value, right? Because it kind of curves strangely there. So who wants to make a prediction what will happen on the next graph? Where do you think it will, how do you think it will look? What do you think, Landon?
The opposite direction.
Maybe like a reflection of the green one?
Yeah.
Yeah, kind of like how the red and blue were reflections? Okay, so let's try it. Let's go back to our graphing calculator. And I've got y equals -2. 1 divided by 2. Yep. Got ourselves a reflection there. So then when I go to my graph, I'm going to use orange for this one. I've got 0, -2, 1, -1, and 2, or excuse me, -2, -8. We've got all sorts of things happening here. And again, your colors might not be the same as mine. That's okay. We've definitely got a cool design, right? And that's not terrible to look at. And if I zoom out, notice how the lines on the x-axis never cross the x-axis. Why is that? Why don't the green and blue and purple and red ever cross the x-axis? Just like with the radon levels in the basement, they're never going to be 0 or less than 0. Why?
Oh, I was gonna say that, but I actually asked my parents about it, and my dad said we don't have one of those things in our basement. He said he knows where it is, but we don't have one.
What?
Were you like, hey, Dad, let's get one?
No, I just said, oh, my teacher said everyone has one. So, and then I just.
Wait, what? Dad, you don't have.
Well, it's at certain levels, it can be harmful, but you can't smell it, and it doesn't have like a color, so you would never know it's in your basement.
And then you can like that.
Well, you can't. I don't think you can die, but if you would not, you might find it like, hey, I don't feel great when I go in the basement. Like, I have a headache, or I get a stomach ache, or yeah. Okay, so let's answer some questions now about these. How do you guys feel about using the graphing calculator? Because you're going to have to use it on the quiz next week. Are you feeling like you know how to put the information in? You know what to select? Yeah? Okay.
On the test, will there be like the tables that we have to fill in?
I don't think so. No. Everything okay?
My graph doesn't look the same, but it looks like not the same at all.
Okay, bring it over here. Let's see. Oh, it's just because your scale is different. So do you see how your scale goes by halves here
Yeah.
and by one, like by two? It's like 2, 4, 6, 8, 10, and then these are halves. So it's just like spread out. That's all. It's just because your increments are different. But
Okay.
the math is fine.
Okay.
Yeah. I don't know how your increments got like that, but that's all. That's all. It's just like it's zoomed differently. Yeah. Okay. So let's answer some questions here. How does a graph change if the value of A changes from a positive value to an opposite negative value? So let's recall that we have f of x equals a times b to the exponent, right? So this is our A value. So what happens if A goes from a positive to a negative? So we had positive 2, negative 2, positive 2, negative 2. What happened? Eden? It reflects, right? The graphed line reflects. Over the x-axis, right? That's our A value. So it went from 2 to negative 2, it flipped over the x-axis. From 2 to negative 2, again, it flipped over the x-axis, right? You can kind of see how those would be a mirror of each other. How does the graph change when b is greater than 1 versus when b is a fraction? So right here, I want you to write fraction, because sometimes people get concerned when they see it as an inequality, but all we're talking about is a fraction. So how does the graph change when we went from having 2 as our b value, which was a and b on the left, and a half as our b value from a and b on the right? How did it change? So this one reflected over the x-axis. What did these do? So if I look back at this and I look at them all together, right? So let's compare the red and the green line. What happened? It reflected over the y-axis. And then my blue and purple lines also reflected over the y-axis, right? The only difference between those is that the A value is either positive or negative, okay? So how does the graph change here? The graphed line reflects over the y-axis. Oops, you guys can't see that, I'm sorry. I'll show in just one second where it goes. It's number 4 on page 10. Right? So the A value affects if it is where it is on the x-axis, and the B value affects where it is on the y-axis. Is everybody still with me? Sort of? Okay, let's turn the page. Okay.
Wait, why is it page 11?
So these were individual full-size pages, and I shrunk them down so that you wouldn't have like a 12-page packet. So it's 2 to a page. So if you look, they all have, it's like 7, 8, 9, 10. Also, the numbers replicate. There's a lot of number 5s in this packet, so this way I can say page 11, number 5. Not just like page 2, number 5.
Okay.
Or page 6, number 5. See where I'm going with that?
What?
You with
Oh,
me?
yeah, I got it.
Okay. Complete the tables below for each function. All right, so we have these two functions. F of x equals 2x, g of x equals 2 to the x power. So in your calculator, so I'm going to get out of my graphing calculator. Oops. Right. because you're going to get some really tiny values. So let me pull up another scientific calculator. I mean, these are pretty easy, right? -4, -2, 0, 2, 4, 8. Excuse me, this should be 6, 8, 10, 12. I don't really need a calculator for that. Two to the -2 is 1/4. 2 to the -1 is 1/2. Remember, anything to the 0 power is 1. Okay, so this is where you're going to want to choose 2 different colors to graph these. Now I know the 1/4 and the 1/2 are going to be almost impossible to decipher because this graph is actually so small. But I'm going to make my f of x graph in red and my g of x graph, it's purple because I couldn't find a blue. I mean, clearly we can't graph all of the points. We're just going to graph the ones that we can. Was anybody on our team involved in the situation at lunch today?
Like, why? Near the fight or same? There was someone trying to separate it. That's on our team. That's on our team.
Who was it?
Jackson, Craig,
Okay. But everybody else steered clear?
yeah.
Okay. Making sure.
Why are we doing here?
Okay, so clearly we have 2 completely different looking graphs. One is linear, one is nonlinear. Which color is linear? Red. Which color is nonlinear? Blue or
Wait,
purple or whatever you have.
Did your 6, 12 one, is that like kind of off graph.
Yeah, I mean, that's not, yeah. I just stopped at 510 because that's how, yeah. And then I extended it this way because it's clearly linear, so I could. All right, Jason claims that the output of this function will always be greater than this function. So he claims that our y values are always greater than our y values for this one. Remember, this f of x is a fancy way of saying y, which is our output, right? We all know that. Input, output, independent, dependent. Make a prediction regarding if his claim is true or false in the space below. So would the y values always be greater than for the purple line? True or false? Addie's saying true. Why do you say true over there?
Because it's exponential growth. It's gonna get bigger and bigger.
Okay. All right. Anybody else have a thought on that? Hayden?
There's two of them where they are the exact same output.
These do have the exact same output, so that's definitely not greater. Any other thoughts? Okay, let's just write down our thoughts here. I just noticed that I made these negative, and they're not supposed to be negative. Did anybody else notice that? You just didn't tell me? Alex? Did you notice that? You didn't tell me? Anybody else notice and didn't tell me? Kike? Nolan? Guys, come on. Addison? You guys are supposed to correct me if I make a mistake like that. This line should be up here. Now it just looks terrible. Oh, goodness. So this should go along here. I mean, it's sort of better-ish. Was yours right, or did you guys all change yours to mine?
How did you erase yours?
How did I erase it? I don't know. I didn't really expect it to erase. I don't know. Okay. According to the graph, which function has a greater value over the interval -2 to 0? So which graph has a greater y value between -2 and 0? So if I'm looking at the -4, -2, 0, 1/4, 1/2, 1, which one has a greater value? Yeah, the purple one. Because even though they're fractions, fractions are still, like, positive fractions are still greater than negative whole numbers, right? Hold on a second. positive fractions, so 1/4 and 1/2, are still greater in value than a -4 and a -2. Right? Even though it's a fraction, so you automatically in your brain you think it must be smaller. It's still a greater value than a negative value. Okay? Which graph has a greater value between 1 and 2? I know Eden knows this. When x is between 1 and 2, which one has a greater output value? Addison?
Aren't they the same?
They're the same. Trying to trick us. No tricks to be had today. How about when x is greater than 2? Eden?
G of X.
Yep. Because it's increasing exponentially. Was that a sneeze?
Yes.
Bless you. Yesterday I said bless you to someone that coughed and everyone thought it was terrible, so I just like to ask now. It wasn't a sneeze. Oh, okay. Sorry. Trying to be nice.
If it was a cough, I probably would have said it yes anyway.
Because you're polite. Yep. It's fair. If somebody said bless you to me and I didn't sneeze, I certainly wouldn't yell at them for it either.
What the heck?
Jeez. Okay.
How dare you?
Return to your prediction from item 7. Is Jason's claim correct? We know it's not. You okay, Cece? Yeah? MJ, you alright over there? Lux, how are you holding up? Okay, just making sure. Elizabeth, you okay back there?
Yeah.
Okay. Trying to fill in yesterday's work too?
Yeah.
That's fair. Okay, we're going to stop there. I guess we didn't finish it. We're close though. Tomorrow we'll do some practice problems.
That was good.